in the first half, we have learned about the distance problem of the two objects traveling in the opposite directions. But what if the two objects are traveling the same direction? Two objects are moving in the same direction, one travels faster while one travels slower. If the slow one is in the front and the faster one is in the back, after a period of time, the faster object in the back can catch up with the slow one in the front. And this kind of problem is called the catch-up problem. And yeah, it's just so obvious, isn't it? Okay, so let's try these questions. Well, here's a quick warm-up. There are two cars, A and B. Car A is 60 kilometers in front of B and has a speed of 15 kilometers per hour. The speed of car B is 45 kilometers per hour. So in time, since car B is traveling much faster, 3 times faster than car A, he will catch up in time. If the two cars set off in the same direction at the same time, before car B catches up with car A, what are the similarities and the differences between the travel of the two cars? How long would it take for car B to catch up with car A? So what is something similar here? Well, the direction of the travel is the same, right? Yeah, the travel direction is the same. Yep, same direction and same time. Yes, 3 hours. Time will flow equally to both of them here. But then what's the difference? The speed is different, and the distance traveled by them will be different. Okay, so let's take a look at the animation. This is what's going to happen in the end, in time. So the catch-up distance is the distance between two cars when the fast car starts to catch up with the slow car. The duration from the fast car starts to catch up with the slow car until it catches up with the slow car. The difference of speed is the difference between the speed of the fast car and the slow car per unit of time. Now, this is the one that we're going to use now. Previously, our speed was a combined speed. Here, it has to be the difference of speed. So basically, it'll be the speed of A minus speed of B. And the time will flow equally to each other. And that's going to go to the distance. And this will be the distance between each other. There we go. So that's the only difference, guys. Previously, it was A plus B. The only difference here is A minus B, so subtraction. Okay? So there we go. These are the relationship, but you really don't have to memorize this relationship. That just comes from the pyramid. It's the same thing. Because the distance in this case is the distance between each other and the time it takes for for one of the cars to catch up, and the speed is the difference of speed. That's the only difference. Okay? So if it was for the previous question, it was 45 and the other one was traveling at 15. And we would want to look for how and they travel for, what was the question? I can't remember. Let's go back. How long? Yeah, we're looking for time. How long? So it's 45 minus 15 times that by t. Oh wait, but we don't know how far ahead they are. So but yeah, in time it could be it's gonna be in 2 hours. And there are 30 kilometers. Yep. So 30 times it by time would equal what does it say? If the two cars set off in the same direction per hour for two cars. Yep, it'll be 2 hours. Yes. So let's try the next question, guys. The tiger sees a deer 100 meters in front and starts to chase it, but at the same time, the deer starts running forward at 10 meters per second. The tiger runs at 20 meters per second. Now, how long would it take for the tiger to catch up with the deer? Well, the deer have to run fast. Here's the tiger, and here's the deer. Deer is traveling at 10 meters per second. Now, be careful with your the units. And the tiger is traveling at 20 meters per second, and it's going to be 100 meters apart. So how long would it take for the tiger to catch up with the deer? So we want to look for time, right? Oops. Time is going to equal to distance over the distance apart from each other and the difference of speed. And that's going to equal to 120 minus 10, and that will equal to 100 divided by 10, which equals to 10 seconds. It will be in seconds because your unit is in terms of seconds. Very good, guys. That is excellent. I love to see that. If you guys can get the answer before I do, you guys are doing great. Keep it up. That's what I want to see. All right, so that's what you guys have to do. It's just the same thing. It's just a different scenario. Same relationship. All you have to do is to look for the difference of speed. Now, any questions here? It's not too hard, is it? It's just exactly the same. So, when you guys come across a catch-up question, for any catch-up question, you'll always find the difference of speed. And when you're looking for the time when they're going to encounter, you'll always want to add the speeds. Okay? Oh, yes. I'll give you a screenshot of this one if you want. There we go. There we go. Very good, Jake. Alex, is that okay? Yep. I got a screenshot for you. It's over there. You can hold on to that. Okay. Now, I want you guys to try this question. Jim and his dad ride bicycle for exercise. Jim's speed is 200 meters per minute, while dad's speed is 300 meters per minute. And Jim is 2,400 meters in front of dad. And how long will it take for the dad to catch up with Jim? Okay. Now, guys, hold on to your answers. Please, let's let other friends have a go. Since you guys are confident, I'm going to give you guys 2 minutes. And I'm sure you guys can manage this. Okay, so let's try this. Ready? Here we go. And Mia, you're going to be next. Thank you, Lucas. Very good, guys. So next week, we're gonna continue the study. We're gonna learn the second part of the distance problems. So if you guys understood this topic, next week's content is gonna be a piece of cake. People think the distance problems are quite is a challenge, but if you understand what's happening, and you just remember the pyramid, we can solve anything. Dad, Jim. And make sure you guys always draw the diagram. It's a good practice, and you guys have to do it. And just be careful with the unit. If imagine you didn't have the multiple choice, you have those multiple choices. You guys would have to write down your own units. So just be very careful. And we're looking for time. Okay, now Mia, please come up on stage. Mia. Hi, Mia. How did you solve this so quickly?
So we did 300 take away 200, which equals to 100.
Very good.
And then 100. Wait, no. 2,400 meters apart. And then divided by.
Yeah, I'll write it down for you. Yep, 100.
Divided by 20. 100 equals to 24.
Yep, 24. Oh, that's a multiplication sign, just by the way.
Yeah.
Yep. So 2,400 divided by 100 is 24 minutes. So, very good. And since our unit is in terms of meters per minute, it'll be 24 minutes. Very good. You have to subtract them, subtract the speed, and you'll get your answer. And I can see that you use this relationship. Excellent, Mia. That time is equal to distance over the difference of speed. Very good. Excellent. Well done. Well done, Mia. And well done for those who got who got B for the answer. Well done. Here's your trophy. 28 of you. Lucas, are you okay? You good?
I just accidentally
Right.
D.
Yeah, that happens. Don't worry, Lucas. Thank you. Well done, guys. Awesome. Now, let me just check if you guys are okay. Could you please press A if you're okay? Press B if you need a little help here. Let me help you out. So everyone's okay. Jess, you're okay. Selena, very good. Bria, good. Ethan, Eva, very good. Okay. Okay, everyone's feeling okay now. Alex, good. Benji, alright. Okay. Shelly, Quincy, Benjamin. What about these students? Ting, are you okay? You good? Oh, okay. Very good. Alright, guys. Now, let's move on. Looks like all of you are confident with these questions. That is great. Now, let's go to this one. A motorcycle drives out of city 60 kilometers per hour. 30 minutes later, a car drives out of city A at 84 kilometers per hour along the same route to catch up with the motorcycle. Now, how many hours will it take the car to catch up? So, guys, this is just exactly the same as before, but we just have this one extra step that we have to consider. Previously, they've provided you with the distance apart from each other. Here, we don't know that distance. You have to derive that distance first before you move on to our regular steps. So A is over here, B is over here. A is traveling at 60 kilometers per hour. B is traveling at 84 kilometers per hour. But we don't know this distance just yet. But that's the distance traveled by A for 30 minutes. So A had a head start. So A's been traveling 30 minutes. So all you have to do is just find the distance traveled by A, which is going to equal to the speed of A times by the time traveled by A. So speed is 60, and you have to look at the unit. Our speed is in terms of in kilometers per hour. If it's been traveling for 30 minutes, that's going to be 0.5 hours, or a half an hour. So, what's half of 60? That'll be 30 kilometers. So, A travels 30 kilometers ahead of B. Now, after that, it's just going to be exactly the same. So we've done all those steps. I'm going to move that over there. And all you have to do, once again, just to use our relationship. We're looking for how long it will take for B to catch up to A. So we're looking for time. So it'll be distance between apart from each other and divided by the difference of speed. So time would equal to 30, which we found here, divided by 84 minus 60. And that equals to 30 divided by 24. And if I simplify this, let's divide the top and bottom by 3. I should have used 6. Oh, not 6. Should use something else. Now, that's going to equal to 5 on 2. And that's going to be 2.5 hours. Oh, sorry, I made a mistake. Why is that 2? That's 4. Now, that's going to 1 and a quarter, so that's going to 1.25 hours. And that's why B is the correct answer here. It's going to take B will catch up with A after 1.25 hours. 1 and a quarter hours. Okay? Yep, Mia, you okay?
I don't get why how did you get like 30 km?
Oh, because that's the distance traveled by A. Because in this question, we're not given with the distance apart from each other. So in order to know that, in the question, the only information we know is that A had a head start. First, he started at 30 minutes before B. So A has traveled for 30 minutes at 60 kilometers per hour. So 30 minutes in terms of hours is half an hour, right?
So 60 divided by 2, it's 30 km.
Yep, or if you're confused, just use this relationship. Time is half. Just going to be half. Speed is 60. 60 times it by half is 30. So A traveled 30 kilometers ahead of B. Okay, so that's just one extra step to the compared to the previous question. All right. Okay.
Okay.
Yep, just exactly the same thing. All right, thank you, Mia. Let's try the next question. Now, are you guys all okay? You guys good? Yep, all right. Very good, easy. Yes, of course, Alex, of course. I'll do that for every single question. Yep, there we go. All right. Now, surprise me again with the next question, guys. A rides a bicycle at a speed of 16 kilometers per hour, while B rides a motorcycle traveling at 40 kilometers per hour. Both have to travel from the east to west to the city. A sets off 1.5 hours earlier, and B goes along the same route to catch up with A. How long would it take for B to catch up? Okay, now, it's the same thing. I'm going to give you guys 2 minutes and 30 seconds for this question. The only information that we know is that A traveled 1.5 hours earlier, so he had a head start. Okay. Oh, I didn't press the selector tool. There we go. Sorry, guys. I'll put it at the bottom. So you'll have to find the distance traveled by A first. Oh. Very good, guys. Jess, Eric, Alex, Jay, Christina, Aiden, could you guys please double check? I think there was a calculation error. I'm sure that's going to be a calculation error. Pollyanna, Lee, could you please double check as well? Very good, Bria. Excellent. Benji, could you please double check? There we go, Aiden, there we go. Jasper, awesome. Abraham, excellent. You got it. Quincy, very good. Very good, Eric. There we go, Benji. Yes. Excellent. Paylin, Selena, Heather, could you guys please double check? Jay, could you please double check? Very good, Cindy. Very good, Palin. There we go. Kingsley, Now, I want to let some other students to try this question. Anyone like to try this question to answer? Anyone like to answer this one for me? Other than Lucas, Mia, and Victor? Anyone else? Emma. Okay, very good, Emma. I'll let Emma have a go.
Okay, so basically you want to know what the question mark is. Okay, so first of all, I can't draw because I'm on my mouse.
Oh, don't worry, you can say it. I'll draw it for you.
I don't have a pen. Okay. Okay, so basically you want to find out what question mark is. So the speed A travel, so that's 16 times 1.5, which is 24. So 24 kilometers between. And then using the pyramid, you're looking for the time. So time to the distance side of it. Speed, so your distance is 24 and your speed is 40 minus 16. Yeah, 24 divided by 24 is 1. So it's 1 hour.
There we go. Very good, Emma. There we go. Nice and easy. Excellent. Very good, guys. So that's how you do this question. It's the same thing. All you have to do is to first find the distance traveled by A. Distance traveled by A, let's just say that that's distance traveled by A equals to the speed of A, which is 16, and the time he traveled before B. He's been traveling 1.5 hours earlier, and the speed of A is 16 kilometers per hour. So the distance will be 24 kilometers. And that's the gap, that's the distance apart from each other, and that's the distance that B have to travel at least to catch up with A. So 24, the difference of speed is 40 minus 16, which equals to 24. So in 1 hour, the motorcycle B is going to catch up with A. And it's true. After 1 hour, A traveled another 16k. So in total, that's 40 kilometers from start, right? And in 1 hour, B is going to travel 40 kilometers. So they are going to meet. B is going to catch up after 1 hour. So that's how you guys can check. Well done, guys. So here's your trophy. Well done. 25 of you. Very good. Now, we have discussed traveling in opposite directions problem and catch-up problems on a straight line. In real life, we often encounter similar problems on a circle. For example, in a circular playground. How can we solve these type of problems? Now, A and B are running on a 300-meter circular track for exercise. If A and B start side by side in the same direction at the same time, A runs 5 meters per second and B runs 3 meters per second. How long after the start will A meet B again? So this is a circular track. what do we have to do here? Well, if you guys think about it, because the two people start running at the same time, side by side, in the same direction, it can only be when the faster one runs a full circle ahead of the slow one that they will see each other again, right? So the catch-up distance is a loop of 300 meters. So you guys have to just assume this in a straight line, and it's going to be exactly the same. Remember the encounter question? If this is A and that's B, that's going to be 300. And they're going to travel in this direction. A runs 5 meters per second, B runs 3 meters per second. Because the reason why it's 300 meters is one revolution, because if you're looking for another time that they're going to meet, one of them have the quicker one, well, A traveled 300 meters anyway, so he already made one lap. Okay, so all you have to do is the same as before. You just have to add, remember, we want to look for time. Time equals the distance apart from each other and the combined speed, sorry. Distance is 300, the combined speed is 5 plus 3, which equals to 8. Now, what's 300 divided by 8? It's going to be 37.5. Oh, did I make a calculation error somewhere? Oh no, what am I doing? Gosh, it should be the other way around. Guys, is some of you having, can you guys see the screen? Yep, Avery, yep, good. Okay, guys, sorry. What I just found is the answer for the next question. This question should be, they should be traveling in the same direction. My bad. My bad. It should be the difference of speed. Yes, it should be like this. Speed. So A is over here. This distance should be 300 meters, and B is like that. Oh, what's wrong with my diagram? There's something wrong with my diagram here. Yeah. I'm getting messages that some of you guys can't see it. Is everything okay? Okay. All right. Is it okay for you? All right. So it's going to be 300 meters plus 3x, which is x is a distance, is a number of seconds after the start, will equal to speed of speed of A. So what I'm going to do, I'm just going to use my quick algebra. So that's 3x is a time. Let's just use t, just for convenience. Let's use time. And that's going to equal to the time 5 times it by the time times it by t. Yeah. If you guys are having trouble, can you please try to re-enter the class? Yes. That's the only way to solve that issue. Now that's going to be 2t. Now the difference of speed. And that'll be the time it takes to cross again, to catch up, will be 150 seconds. So if I draw a straight line, this is A, and if that's B, and if they're 300 meters apart, and that's B is traveling at 3 meters per second, and A is traveling at 5 meters per second, it's the same thing as the straight line question. Oh, but they will join back because they're going in a circular track. What I've just drawn, just because they're running in a circular track, the logic is the same. It will happen. Because the only time they're going to meet again is after one lap. It's after one of them made a lap. And that is why these questions are exactly the same as the questions on a straight line. That's the trick. Just because the track is different doesn't mean that the logic is not going to be applied here. And that's why, remember, I'll show you a different way. It's the same as time equals to the distance between each other and the difference of speed. Distance was 300 meters, and the speed is 2. The difference of speed is 2, which is 150 seconds. And that's why the answer is going to be D. Okay, so I'll say that again. So because the two people start running at the same time, side by side, in the same direction, it can only be when the faster one runs a full circle ahead of the slower one that they will see each other again. So the catch-up distance is a loop of 300 meters, and you just have to assume that as a straight line. Yes? Okay, is it laggy? Oh no, what's going on? Yes, Lucas? Oh, where are you, Lucas?
For like the answer for the first one, like you said it's D, but like technically it says that A and B, they're asking how long after the start will A and B meet again. But like technically 120 seconds, doesn't that mean that 5 meters times 120 seconds is 600 meters, and like 3 times 120 is like 360. If the whole circular track is a 300-meter track, doesn't that technically mean that because A runs 2 circles, he's gonna meet B because B only runs 1 circle technically?
Oh yes, but 150 will still be correct here. It will be applied, and yes, if you sub it in, they will be equal. 150 seconds. So I said that it will be after 1 revolution, but it will still be applied. It's still going to be the same. How about you sub in? Yep. How about you sub in that again? And you'll see that it will be applied equally. It will be the same. Because the first revolution, the same time has already applied. So we're looking for the time after that, which we can just disregard the first start. Okay, just sub it in and it will work. Okay, the next one is asking us if A and B start side by side but in an opposite direction. A runs 5 meters per second, so it's the same thing. So when are they going to encounter each other? So that's a sort of question that's going to go in an opposite direction, and that's the same as the first half of our lesson. We're looking for the distance, and you'll have to combine the distance here. Because the distance between each other after every second is going to get shorter and shorter and shorter again. So you have to combine it, and the answer was 300 divided by 8 was 37.5 seconds. So in 37.5 seconds, they're going to encounter each other. If they start this way, one of them started this way, another one started that way. After 37.5 seconds, they're going to come across each other over here. Like that. Okay, so there we go. It's going to be B. Alright, now, you guys are going to quickly try these two questions, and it's just going to be the same. If you guys can do one, the other one's just going to be the opposite. A and B are walking for exercise on a 900-meter circular track. They start side by side at the same point. They walk at the same time in the opposite directions. A walks 50 meters per minute, and B walks 70 meters per minute. Now, how long after the start will A see B again? So you also, once again, you guys have to assume that one of them will have made a revolution already. Okay, now you guys can submit your answers. Let's just answer the first question. You guys ready? Yep. Good. Yes. Yep. Very good, guys. 50 meters when walking. Yeah. 50 meters, actually, 50 meters per minute. No, it's okay. 50 meters is... You're right, guys. It will be B for the answer for the first one. And it is going to be B for the next one again. So the first question is the same as the catch-up question. So since one of them made a revolution, that's going to be 900 meters, and that's going to be B, and that's going to, who was walking faster here? A walks 50 meters per minute. Oh, so that's going to be, that'll be A, that'll be B. So you'll have to look for the difference of the speed, and you'll get 7.5. On the other hand, for the second half of the question, they're starting at the opposite ends, and we're looking for the encounter time, not the catch-up time here. And the distance between each other is one revolution, which is 900 meters once again. And for every minute, the distance between each others are going to get shorter and shorter and shorter again. And that's why you have to combine the speed, and you'll get 45 minutes. Very good, guys. Excellent. Now, what I'm going to do, I'll give everyone a trophy here. There we go. So that's how you do it. So just because it's a circular track doesn't mean it's different. Same thing's going to happen in real life. Okay, so guys, today we have learned about the distance problems, and you really don't have to remember those things. The only thing that you have to remember is these terms. The time travel, the total speed, the catch-up distance. Those are the only terms that you guys have to remember. But all you have to remember is this pyramid. That's all you need. And just look for the term that you're looking for. Just make sure that when you're using the encounter problem, you say the total speed here. And when you're doing a catch-up problem, you have to make sure you say it's the catch-up distance and the difference of speed. So make sure that you guys remember that. That's the only difference that you guys have to pay attention. Okay, so that is it for today, guys. So well done. I can see that you guys are finding this quite easily, so that is great.